Hello everyone, welcome to my YouTube channel. In this video, I'll be showing you my electronics project, a function generator circuit using ICL8038 IC. This circuit can generate sine, square, and triangular waves at different frequencies, and it's a great project for understanding the waveform generation and signal testing. So let's take a closer look to the circuit and how it works, and finally see the output on the oscilloscope in Proteus. So here is the circuit. Uh, let's start with the components used in the circuit. The main component here is the ICL8038, which is a precision waveform generator IC, capable of producing sine, square, and triangular waveforms. Next, we have resistors, capacitors, and that are used for determining the frequency and amplitude of the output waveform. There are also potentiometer, which allow us to fine tune the frequency and waveform symmetry of output. I have used a virtual oscilloscope in the Proteus. This circuit is powered by plus and minus 15 volt dual power supply. Since the ICL8038 requires both positive and negative voltages for a proper sine wave generation.
Now let's understand how the circuit actually works. The ICL8038 contains internal circuit, current source, comparators and shaping circuits that generate precise waveforms. Here the timing capacitor is connected between pin number 10 and 11 along with the resistors on the pin number 4 and 5, determining the frequency of oscillations. By adjusting these capacitors and resistors values, we can change the frequency range, which is typically from a few hertz to few kilohertz. The triangular wave is generated first and then internal circuitry in the IC makes it into a sine wave. The square wave output is obtained directly from the comparator stage of the IC. So from the single IC we can generate three different waveforms, all synchronized and stable.
Now let's simulate the circuit and observe the output. As you can see, we in the first channel we get the square wave, in the second channel we get the sine wave, in the third channel we get the triangular wave as desired. Now let's change the values of potentiometer and observe the changes in the output. Let's change the values of potentiometer RV1. As we increase the value of potentiometer RV1, the wave gets into 50% off time and 50% on time. Now, if we reduce the values of potentiometer of RB1, the on time remains the same and off time gets increased. So we to keep the waveform 50% on 50% duty cycle, we need to keep the RB1 into maximum value. Now let's change the value of potentiometer RV2. As you can see, changing the value of potentiometer RV2 increase the frequency and reduces the frequency, and reducing its value increases the frequency. Now let's check the output after changing the value of potentiometer RV3. As we can see, changing in the value of RV3 changes the sine wave, which is not desired. So to keep the sine wave stable, we need to keep it at minimum value. Now let's change the value of potentiometer RV4. The potentiometer RV4 also makes changes in the frequency of the output. As you can see, increasing it reduces the frequency, and reducing it increases the frequency. These are the changes we can see after the changing the value of potentiometer. This ICL 8038 based function generator is useful in various applications such as testing and troubleshooting amplifiers or filters, generating reference signals for experiments. And as this is a very simple low cost signal source, so that's why it can be used in very small projects easily. So that's how the function generator circuit works using ICL 8038. It's compact, reliable, and educational project for electronics. I hope you like this video and help you understand the working and applications of this circuit. If you like this project, don't forget to like, share, and subscribe. and all the required details like circuit diagram and the data sheets used in the circuit are in the description. And don't forget to like, share, and subscribe.